Greetings, we are continuing with our lectures on heat pumps and refrigeration cycles. Today we want to look at water as a refrigerator. So can we use water as a refrigerant? This is normally a challenge because water is known to have very low vapor pressure. Water has low vapor pressure and has high specific volume. Those are two key disadvantages for water. Can't be used basically because one has low vapor pressure and number two has high specific volume. Has high specific volume. And so this makes it a challenge to use water as a refrigerant. And so even in air conditioning plants, maybe you can achieve the required vacuum, but in general, even at probably very low temperatures, maybe let's say at temperatures of 7 degrees plus, you will find that the specific volume of water is about about 129 meters cubed per kilogram. That's a very large flow volume. And the vapor pressure you'll find is about 0.01 bar. And because of this very large volume, in this particular system where you want to use water as a refrigerant, then you're not going to use a compressor, you'll use an ejector pump. So because of the large volume flow, we'll use an ejector pump rather than a compressor. It is preferred to use an ejector pump rather than a compressor. And if you go to our previous discussions, you're going to see where we have used compressors in this type of systems, but where we have water as a refrigerant, we'll use an ejector pump. And an ejector pump, let's just draw diagrams. Not very accurate, but illustrative of an ejector pump. So an ejector pump very accurate. This is a sketch of an ejector pump. So we have high pressure steam, from boiler, and we have low pressure steam where we have our nozzle, and we have our mixing cone, our diffuser. So let's say something about this ejector pump Here you see we have high pressure steam from boiler. It's expanded in the nozzle. Leading to the formation of a high velocity jet at low pressure. Remember from our discussions on nozzles. So just in case you don't remember, just go through our lectures on nozzles. So what you have here is this high pressure steam will be expanded in the nozzle, resulting in a high speed jet at low pressure. The high pressure steam is expanded in the nozzle, resulting in a high speed jet, high velocity jet at low pressure. Of course, this will entrain the vapor from this low pressure, and they will be mixed at the mixing cone, so that mixture, so the vapor is entrained steam is entrained, and at the mixing cone the mixture which you have at the mixing cone will diffuse into this venturi. The mixture, so the mixing cone, the mixture will diffuse the divergent until we obtain the appropriate pressure. So this let's call this intermediate pressure of the mixture. Mixture, very simple. So we have just the high pressure steam will expand in the nozzle, leading to formation of a very high velocity jet, which entrains the vapor from this vacuum. And in the mixing cone, that mixture will diffuse into that divergent, section of the venturi, and of course, until we get whatever pressure we want, whatever pressure which you want. And now, how do we use this ejector pump when we are having this particular plant where we are talking of it as being a water refrigerator? How do you use it in the water refrigerator? Let's see how we use it. So, in the water refrigerator, we have our condenser, and we have our evaporator, in case you have forgotten, let's go through our notes, earlier notes. So we have our condenser, and of course we have our evaporator. So in this unit here, we have our injector pump, trying to do it as best as you can. can sort of clear the cool air. We have evaporator, we have water. At low pressure, it will evaporate. And of course, we have our motive steam. So the water from the evaporator will evaporate. It will mix with the motive steam up to the condenser. And in the condenser, the condensate can be throttle backed. Remember we talked about the throttling valve, which we talked of as being, when you talk of throttling, you talk of constant enthalpy processes. So if you look at our earlier lectures, you'll see that. And then of course, some will go back to the boiler. So we have our ejector pump. So the water evaporates, makes the motive steam is driven to the condenser, where the condensate, some can go back to the evaporator by the throttling valve, and the other can go to the boiler. So if we have a certain fraction, so if we have x and y of this mixing, so then we have x plus y, so some portion of it will throttle back to the evaporator, and others will go back to the boiler. So that's just a simple process. So we are saying that the water in the evaporator, the water vaporize, mix the motive steam, driven to the condenser, where the condensate there are a portion of the condensate, where a portion of the condensate